Today we'll be starting the second part of this chapter, chapter 9. So the first part we looked at logs and exponentials. In this section, we're going to be looking at different ways of measuring angles. And this method, this format is called a radian. So far, all of our calculations for angles, we've been using degrees. And we talked about 360 being a revolution. Now, you might ask, why do we use 360 degrees? Now, the main reason why we have 360 in a revolution was really based on astronomy, so back in the days. So 360 was a really good, really useful number because it had so many factors. So if we needed to split our circle into a certain number of parts, it was much easier to work them out using 360 as a number to represent lots of sections. Now, the problem with using 360 is that when we talk about a revolution, once we've gotten around the whole circle, we call that 360. But then if I want to keep going, I need to then start from the beginning again. So there's no way of working with angles that are larger than 360. So we did do a little bit of trigonometry before when we looked at obtuse angles, we looked at reflex angles, and to some extent we also looked at angles that were larger than 360, but we couldn't represent that in any way, shape or form on a circle or in a triangle or anything like that. So when we're working in mathematics, we use radians a lot. So how we calculate a radian is the size of an angle in radians is the ratio of the arc length to the radius of the circle. So basically, what we're saying is if I have a circle, and I've got the radius, when I'm talking about the angle is that length over the radius. Okay, so that's going to be how we calculate that number. So it's the arc length, okay, arc length here. So whatever this length is divided by the radius, that will give you the number for the angle in radians. So if we're talking about going around a complete revolution, so if we went the whole way around the circle, we know that the circumference is 2 pi r and the radius is going to be r. So if I go the full length around the circle, it's going to be 2 pi r divided by r radians, or we can say a complete revolution is 2 pi radians. Okay, so that's just how we label the angle now. So in other words, if we wanted to change from degrees to radians, we can say 360 degrees is equal to 2 pi radians. Okay, so there's certain angles that we do use a fair bit of, and these are the ones here. So what I've got here is all the main ones. So you can see 30, 45, 60, 90, and then you can see that's your second quadrant, third quadrant angles, fourth quadrant angles. And they're all the angles where 30, 60, or 45 are your related angles. These are the ones you'll see the most of. It's probably worth remembering which one's which, or at least you want to be able to convert between the degrees and the radians easily. So just to start off with, we know 360 degrees is 2 pi. So if I've got 180 degrees, we know it's going to be half of that. So that's going to be pi radians. If I go half of that again, 90 degrees, that's going to be pi on 2. Now what we can do is we can work out all of these this way. So 90 is pi on 2, 45 is going to be pi on 4. Okay. So if we were to work them out using this relationship, 360, in order to get 45, you're going to need to divide by 8. So then you're dividing 2 pi by 8 in order to get pi on 4. We can go up a bit, so 225 and 315 are the other angles which 45 is the related angle for. So 225 is going to be pi, and then this is an addition of 45 degrees, so it's going to be pi plus a quarter pi. So this angle here, 225, is going to be 5 pi on 4. Oh, forgot about 270. 270, so halfway between 180 and 360, we've got 1 pi here, 2 pi's here, so that must be 1.5 pi's, or that would be 3 pi on 2. Let's just fill those in as well. We've got 135 degrees. Okay, that's halfway between 90 and 180. So halfway between pi on 2 and pi, so half of pi and 1 lot of pi. Halfway between those two numbers is going to be 3 pi on 4. Hopefully with a lot of practice with this, your fractions will get really good too. And 315 also has a related angle of 45. So halfway between 3 pi on 2 and 2 pi is going to be 7 pi on 4. Okay, if you're not sure, what you might want to do is just put those into your calculator. So to get this number, what we can do is we want halfway between 3 pi on 2 and 2 pi. So we're going to average 3 on 2 and 2. Okay, so add them together, divide by 2, you'll get 7 over 4, and then you can put the pi back on. All right, so that's all of the angles for 45. What we might want to also do now is, because we've got 360, let's go work out 60 degrees, okay? We can see 360, if I divide by 6, I'll get 60. So if I take 2 pi, divide that by 6, I'll end up with pi on 3. We can see 120 is double of 60 degrees, so that's going to be 2 pi on 3. And we can use these patterns in order to work out each of those angles. We can also see that 60 is twice of 30 degrees. So if I halve pi on 3, then that's pi on 6, and so on. So what you want to be able to do eventually is you want to be able to recognize each of these for their corresponding degrees. The more you practice them, the easier it will be for you to recognize them, and then you'll be able to do your calculations a lot quicker. In actual fact, radians is the way that we need to be working with angles in trigonometry when we get into the calculus of trigonometric functions. So let's keep filling these in. 150, that would be, what's the easiest way to get there? We could go 120 plus 30. So we've got 2 pi on 3 plus pi on 6. So you can work out the fractions there, so you can put them in your calculator, or that's going to be 5 pi on 6. Another way you could have worked it out is gone 180 minus 30. So you've got 1 lot of pi and you're taking off a 6. So 1 minus 1/6 is 5 over 6. When we get to 210 degrees, that's 30 bigger than 180 degrees. So we're going to take pi plus pi on 6, which is 7 pi on 6. To get 240, now the easiest way to work this one out is probably going to be doubling 120 degrees. So that'll be 4 pi on 3. When we get to 300, now again, let's find an easy way of getting there. We could go 150 times 2. So 5 pi on 6 times 2 will give you 5 pi on 3. And then 330 degrees is 360 minus 30. So I've got 2. If I take off 1/6, that's going to be 11 pi on 6. So lots of practice with fractions. So again, if you can't work them out straight away, that's okay, perfectly fine. It does take a little bit of getting used to, particularly because you've been using degrees your whole life, and suddenly, in the second last year of high school, we're throwing in some radians. But the more you practice working with them, so at first you might be working everything out in degrees and then converting them to radians, but the more you encounter them, the more you practice with them, the more comfortable you will be with working with radians. Now, so we've worked out what these values are, so what each of those degrees translate to. When we're looking at radians, there is a symbol that we use, and it's a little c. So you know how with degrees we write 40 degrees as a little circle? Radians we can write as a little c in the top corner. Okay, so if I wanted 3 radians, I could write that as 3 with a little c. But sometimes that can get confusing because it isn't really used as much in our textbooks. So usually when we want to write that something's in radians, we'll just actually write out the whole word. So we'll just say 4 radians, like we'd actually write it out. Okay, or it could be a decimal. Decimals are fine too. It could be expressions in terms of pi, like what we found above. Now, if we want to convert from degrees to radians, so we had 360 degrees equals to 2 pi radians. So what that means is 180 degrees is equal to pi radians. So if I want to go from degrees to radians, what I need to do is I need to convert this into what 1 degree is. So if I divide both sides by 180, that's going to be pi over 180. So 1 degree is pi over 180 radians. So if I've started with a certain number of degrees and I want to change to radians, we're going to multiply by pi over 180, which is what we've got here. If we want to go backwards, then what we want to do is we want to end up with 1 radian, so 1 on the right-hand side. So we're going to divide that pi over to the degrees side. So that's 180 over pi. So 1 radian is 180 over pi number of degrees. So if I have a certain number of radians, then I can work out the degrees by multiplying by 180 over pi. Mainly, all you really need to remember is this. Once you know this, then when you go to convert, you can convert them into the relevant version that you need. So let's have a look at a couple of these ones. Convert the following into radians. So we're starting with degrees and we're going to radians. So we're going to multiply by pi over 180. So 72 times pi over 180. Now, anytime we've got pi, we want to leave the pi in the expression. So we're just going to calculate the numbers. So we'll do 72 over 180, and that's 2/5. So we can write that as 2 pi over 5. We can also have angles that are larger than 360. Again, we'll multiply by pi over 180. So again, leave the pi there. We're just going to calculate the numbers. 495 over 180, and that's going to be 11 pi over 4. For part B, we're converting these to degrees. So we're going from radians to degrees. We're using the second one, and we're going to multiply by 180 over pi. So for the first one, we've got 3 pi over 4 radians. So we've got 3 pi over 4 times by 180 over pi. The way that I like to remember this is when I'm doing my conversion, if I've already got a pi in the expression, so we're in radians, then I need to have pi in the denominator to cancel it out. So that's sort of a nice easy way of remembering which version of the fraction to be using, because we do want the pi's to cancel. So what we've got is 3/4 of 180, and when we work that out, that's 135 degrees. So that comes out to be a nice round number. If I've got 5 radians, so this time we don't have a pi there, so when we times it, we will have a pi. So we've got 180 times 180 over pi. Now, this one was to the nearest minute where necessary. So when we're writing something in degrees, we usually try to work it out into degrees and minutes, okay? So we only leave the pi in if we're writing out the number of radians in an expression. And also only if they don't ask for decimal places. Sometimes I'll ask for decimal places, so just put it in your calculator and calculate. So we've got 5 times 180 over pi. And when we work that out, that's 286.47 something. To work that out into degrees and minutes, what you need to do is press the degree button, the bubble button. And so that's going to be 286 degrees, 28 minutes, and 44 seconds. So if I need to round that to the nearest minutes, then I need to round it up. So that means, take out the 44, it's going to be 29 minutes. So that's how we go back and forth between degrees and radians. Initially, when you get an expression in radians, you'll probably be doing a lot of converting back to degrees in order to do your calculations. But then the more familiar you get with some of these expressions, so like anything over 4, anything over 3, anything over 6, those ones are the usual the angles that we use the most of. Okay, so once you recognize them, it's a lot easier to calculate. Okay, so what we can now do also is we can do some calculations. So we will be using both methods. So when you look at your exam questions, you will see things that are in degrees, you will see things that are in radians. So you need to be comfortable with using both of these different ways of measuring angles. Typically, if a question is given in degrees, you should be answering it in degrees. And if a question is given in radians, you should be answering it in radians. Okay, so that's just the rule of thumb. I can't speak for whether you would be marked down if you use the wrong format, but I'm sure if you've done all your calculations correctly, it should be okay, as long as you've written clearly whether you've used degrees or radians. Okay, so with these questions, we want to find the exact values. So that means we're not putting these into our calculator. So we need to first determine what sort of angles we've got, and then we can calculate each of these exact values. So for the first one, we've got cos of pi over 3. So if you go back up into that table from before, pi on 3 is 60 degrees. And it's right here, 60 degrees. So that means we're looking at cos of 60 degrees, and hopefully you're able to recognize cos 60 as 1/2. For B, we've got cot of pi on 6. So we need to first work out the cot, and we also need to work out the pi on 6. So pi on 6 is 30 degrees. So we can write that as cot 30 degrees. If I've got cot is 1 over tan, so it's 1 over tan 30. Tan of 30, hopefully remember, is 1 over root 3. So we're dividing by a fraction. So then that's the same as saying 1 divided by 1 over root 3. So we flip the fraction over and multiply. So this value is going to be positive square root of 3. Didn't quite leave enough room there. With question C, we've got sine of 4 pi on 3. So sine, now 4 pi on 3, let's go back up to the table, is 240 degrees. So we're going to write this one as 240 degrees. And we need to look at our quadrants now. So 240 degrees is in the third quadrant, 240, and the related angle there is 60 degrees. So if we're in the third quadrant, sine is negative, so it's negative sine of 60. Sine of 60 is the square root of 3 over 2. So minus root 3 over 2. With our last one, we've got sec of 11 pi over 6. Now 11 pi over 6 sec is 330 degrees, right at the end there. So 330 sec is 1 over cos, and 330 is in the fourth quadrant, and the related angle is 30. So if we're looking at cosine, cosine is positive in the fourth quadrant, so that's going to be 1 over cos positive 30. Cos of 30 is root 3 over 2, and so again we need to do fraction division. 1 divided by root 3 over 2. So when we flip it over and multiply, it's 2 over root 3. So that would be the exact value for sec. Now, your calculator will also do calculations in radians, okay? So, but it is important that you do put your calculator into the correct format. So if you remember right at the beginning when you first started to learn trigonometry, the first thing that your teacher would have told you to do is check that your calculator is in D mode. So if you look at the top of your top line of your calculator, there's a D. Well, the D should be appearing, but if you look at the other type things that you could also have is you've got an R and you've also got a G as well. So D is for degrees, R is for radians. So you need to make sure that your calculator is in the correct mode when you're working with trigonometry. If you're in the wrong mode, you will get these questions wrong and you will lose marks for them as well. So to change your calculator to radian mode, what you're going to do is you're going to press Shift, then Mode, and then if you look at the menu, you've got Math IO, Line IO, Deg, Rad, Graphics, Sci, and Norm. We want to go into Rad. So Rad for radians, and if you needed to go back to degrees, you're going into Deg. Okay, so 3 and 4 are going to be the buttons that you'll need, the options that you'll need to use. So we're just going to press 4 for now. Okay, so at the top it should turn into an R, so you should see an R in the top line of your calculator now. So to evaluate these to 3 decimal places, now that we're in radian mode, what we're going to do is we're just going to type these into the calculator. So each of these are in radians, okay, so if that we don't put any symbols on it, it's usually given that it is radians, but if we won't, we can put the little C there just to say that they are. So let's just put these into your calculator. So sine 1, and you will get, we should get something like 0.841. Okay, make sure you check these on your calculator as well. Type these ones in and make sure you're getting the same answer as I am. For the question B, sec of 4.2 radians. So sec is 1 over cos. So we're going to put this in as 1 over cos 4.2 radians. So 1 over cos 4.2, close bracket. So you don't need to put any symbols in for your cos, okay? So for the angle, you don't need to put any, like there's no symbol to put for radians, okay? So once you've put the number in, it's assumed that it's in radians. So cos of 1 over cos 4.2, I've got negative 2.0397. So if I round that up, that should be 0.40 to 3 decimal places. So again, check that you've gotten the same answer that I have. Cos 27, so now we can have really large numbers as well. So cos 27, when we put that in, I've got 0.292. And the last one, we're going to put in tan 0.4. And I've ended up with 0.4227, so 423, correct to 3 decimal places. So make sure you remember what mode your calculator is in at all times. Some other teachers have recommended that maybe when you go into exams, bring 2 calculators in, one that's in degree mode, one's in radians mode, and make sure you're using the right calculator at each time. Okay, so those are ways that can help you to make sure that you're in the right mode, or you just need to remember to change them each time depending on the type of question that you've got.